Hello friends, welcome back again. So in the previous lecture I just informed you that we are doing the electrostatics here, and in which we are going through these topics, okay, starting with the Coulombs law and end up with the method of image and induction of the charge. And in between I explained some basic terminologies, okay, ESBD. These are the basic terminologies which you have to go through the entire syllabus, okay. And I want you to at least memorize these units, because many times they are going to be helpful while solving the competitive exams like junior engineer, etc. Okay, now come back to the Maxwell equations. Okay, so Maxwell equation is that thing which I want you to write at least 100 times before the completion of this course. Okay, so I just request you, whenever I say you write down all the equations, you just have to be honest with yourself, and you have to read out each and everything on your paper. Okay, and take a rough copy and write it down. 4 equations, these are the 4 equations are there. Keep in mind that every equation consists of 1 marks, half marks for this one, half marks of this one, and tell me after writing all these equations how many marks you get in the comment section. All right, so first of all, integral form. Maxwell equation this is the integral form, this is the point form. Always keep in mind that I want you to memorize it. Okay, I want you to memorize all these equations, because these are the most important equations. How the equations came, what is the meaning of this equation, I will little bit later when we are going through the syllabus. Okay, but in between, from starting day to end day, I want you to write at least 100 times before the completion of this EMT, electromagnetics. Okay, so without asking anything, please, as aspirant, what I'm doing, say that what I'm saying, please do that. Okay, all right, come back to the integral form and the point form. In the integral form, what you have to do, the closing integral of d dot ds, that is equal to the q, and d dot del dot d, that is equal to rho v. This is the volume charge density. Okay, and this is basically the Gauss law. Come back to the second, b dot ds, that is equal to the 0. Okay, del dot b, that is going to be 0. Again, close integral of e dot dl, that is equal to the 0. And del cross e, that is equal to the 0. Okay, now keep in mind that this is the line integral here only. Okay, this is the line integral. Okay, when you are closed integral, taking this closed integral, this is the line integral, these are the surface integrals. Okay, so whenever this cross is there, we are doing with the L only. Basically, whenever you del cross apply, it should be del cross apply should be at the this, you can say, the intensity, and ds is applied at the density. Okay, so that is why I am saying close integral of this e dot dl, that is going to be 0. It tells us the rotational. Okay, and this is del cross e, that is going to be 0, and this is the closed integral of lengthwise closed integral of h dot dl, that is equal to current, and this is the Ampere's circuital law, like this is Gauss law, this is the Ampere's circuital law, and del cross h, that is equal to the 0. Okay, some between the mid of the course, when we will start the EM waves, so what will happen, we will study electrostatics. Okay, again magnetostatics, and we will combine both of them to form electromagnetic wave. Okay, so at that time these two equation is going to be changed here. Okay, so at that time we will see these two equations, and we need not to bother about all these things right now, but I want you to memorize. That's why I am saying that. So do it, be the 3rd class, 4th, 5th standard boy, but memorize them. Okay, now come back to the syllabus. Okay, so let's start with the Coulombs law. What exactly is the Coulombs law? Actually, in 1785, okay, let me write 1785. Okay, this is one person, Charles Augustin de Coulomb. Okay, now this is Charles Augustin de Coulomb. Okay, this is the person who gives this law, and after that there is one colonel in the French army is verified that okay, this is the good, it has given this law. But what is this Coulombs law? Coulombs law for the electrostatic charge. So what exactly they said, कि whenever some charge is there, okay, one charge is there, suppose q is there, when you bring some small charge, q charge is there, so it will exert a force on that which is directly proportional to product of their charges. Okay, suppose q2 is there, q1 is charge is there, so two charges are there. This is q1 and this is q2. Okay, so whenever two charges are there, this is q1 and this is q2. So what will happen, whenever these charges are come close to that, there will be a force in between them. Okay, whenever some electric field is there, what is electric field we will be considering a little bit later, because they termed the coin the term force. After that they will drive electric field. Okay, so this is the parameter done by this one, the Coulombs law. But in the Gauss they first termed the electric field, after that we will drive the force, but here we are considering force only. Okay, so basically Coulombs law is that law which we are studied in the 11th standard. All right, in the 11th standard what actually happening, we simply studied 11th 12th standard, or even in the engineering, when two charges are there, there is a force in between them. Okay, so what is the force? This is the along the line joining them. एक लाइन है जो इनको ज्वाइन कर रही है, उसके बीच में एक फोर्स लगती है. वो क्या होती है? फोर्स डायरेक्टली प्रोपोर्शनल होती है इनके प्रोडक्ट की, Q1 एंड Q2. ओके, दूसरा क्या होता है, ये जो फोर्स होती है, this force is the inversely proportional to the square of the distance present between them. Suppose our distance is there in between them, so this force is the inversely proportional to the square of this force. Okay, whenever you combine both the equation 1 and 2, so what you will get directly proportional to Q1 and Q2 by R square. Okay, whenever we will remove the proportionality sign, then use some constant K is there, so Q1 and Q2 is there and R square. So we will determine this constant by making some experiments, and this value K is given in terms of 1 upon 4 pi epsilon naught. Okay, so this is like that, and this is something equal to 9 to 10 raised to the power 9. This is 9 meter per farad. So this is the unit basically, for this constant. Okay, now come back to the points. This is the same thing which I have drawn here. Okay, what I have written over there. For the point charges, in the Coulombs have given this law. What he was saying, two charges, we will put two charges, there is the force in between them. Okay, and this is directly proportional to product of their charges, inversely proportional to the distance present between them, and if you combine that you will get this one. And whenever you remove this proportionality sign, some constant K is there, and this constant is equal to 1 upon 4 pi epsilon naught. Okay, so 1 upon 4 epsilon naught, this is equal to 9 to 10 raised to the power 9, and this is the meter per farad. All right, and what actually happens is the vector quantity. Okay, this distance is the vector quantity. We will take some reference over here. So this is the r1, this is the vector r1, this is the vector r2. So what will happen, this is the resultant vector, this resultant give you, this is the r2 minus r1. Okay, this is the law of parallelogram or law of triangle in the vector calculation we have to consider over that. Okay, so what will actually happening, if you put this as a vector quantity r21. Okay, this is the distance between the point 2 and point 2, vector quantity. So unit vector is equal to r12, that is giving the vector over the magnitude of that vector. Okay, if you put this one in, because this is in the current direction of the a cap r, this is the direction of the vector of the r, radius vector. Okay, so from this vector is directed from 1 to 2, so that is why it is written as a cap 1 2. All right, so whenever you put this one in this a cap r, in the direction of a cap r, it will become to f12, that is equal to q1 by q2 over r cube into this is the vector of r12. Okay, always keep in mind that here 12 is there. It means 12 is there, it means whatever the force on this charge q1 due to q2. Okay, so I have also mentioned it here, that force on charge q1 due to q2, it is written in form of f12. Okay, this is the force, is the vector quantity which we have considered here, and always keeping that whatever the force felt by this q1 due to this one q2. Okay, this is exactly opposite, whatever the force felt by this q2 by due to this q1. Okay, so simply we can write action reaction law. Okay, opposite Newton's law is there, this equal and opposite force are Newton's third law, I think it is there. Okay, so where in the electrostatics F12, it means if some force is exerted on by this charge 1 due to this charge 2, there is opposite force exist by this exert by q1 on q2 on due to this q1. Okay, so equal and opposite forces are there for in respective to each other. Always keep in mind that if point 1 is there, if some force is coming from there, suppose point 1 is there, f1 is exerted from there, f2 is exerted from there, f3 is is exerted, F4 is there, F5 is there, so many forces it can be there. So whatever the total force is there, simply it is the vector resultant of these forces. Okay, keep in mind that vector resultant is there. First of all, if these forces are there, so you have to find out the resultant. Okay, what is the resultant of these force? Okay, again again take the resultant of these two, and with along with the this charge F3 forces there, you have to be again take the vector sum of this force. Okay, you will get the appropriate answer. Now just see this, F12 is the force in the direction of F12. It means the force on charge 1 due to 2 in the direction from directed towards the from 1 to 2. Okay, so for force 1 to 2 1, this is equal to A cap 2 1, and if you convert it into the unit vector of direction, okay, suppose this direction is there from here to there, you have considered this direction. Okay, and this time if this direction you will consider, and what is the relation between these two directions? So whatever the A cap 1, okay, A cap 1 2 is there, so this is equal to minus of A cap 1 2 for with respect to A21. Okay, so what if A12 is there like this? Okay, and so A21 is like this only, and this is equal to the opposite of the A12. Okay, so this is the simply here some explanation is there. So always keep in mind that this force is the linear. Okay, linear force means a linear force is there, linear equation is following y is equal to x, mx is equal to there, so this linear force is there and it act along a line. So this is all about the for Coulombs law. So in the initial lecture I just explained what exactly is the Coulombs law. In the next lecture we will discuss regarding to the fields and what is electric fields, and how by making the use of Coulombs law we can drive the electric field. Okay, again I told you that Coulombs is that person who first tell about force and then drive electric field. Okay, when Gauss is that person who first tell about electric field and say then measure force. Okay, so like that we will use all these things. Okay, in the next lecture we will do that. Thank you and have a nice day.